And welcome to part 4. Gregory here, and we're going to figure out how to use the cubic factor formula to solve this equation right here. It's x to the 3 plus 64 equals 0, and since our degree is 3, that means we should get 3 answers. So these are really easy to do if you know the cubic factor formula. You just want to follow this formula exactly as it's laid out, and that allows us to break it up a bit so we can solve it. So first, if it's x to the 3 plus 64 equals 0, are we going to use this one, or are we going to use this one? That's right, it's a plus, so we should use this one. So here's how to follow the formula. We've got this part right here. This part right here is x to the third plus 64. So that means that a to the third is our x to the third, and b to the third is 64. Do you see how I did that? The a to the 3 is the first x to the 3. The b to the 3 is represented by 64. So once you know what a to the 3 and b to the 3 are, it would be nice to know what a and b are. Well, a is easy. A is just going to be x. Easy enough. If a to the 3 equals x to the 3, then a equals x. And what number times itself 3 times is 64? You might need to play around on the calculator a little bit to get that, but 4 times 4 times 4 is 64. So in this case, a equals x, b equals 4. Now you just want to build this piece all together, just build this, knowing what a and b are. So the signs are all there for you. You just follow the signs. And so here we go. So this is going to be, I do 2 sets of parentheses, one a little longer. A plus b, that's going to be x plus 4. That's easy enough. Then we have a squared. Well, if a is x, a squared is x squared. Then my formula tells me I have a minus sign. Then I have a times b, which would just be 4 times x. Then the formula says I have a plus. And then b squared, if b is 4, then that's going to be a 16. And that's all there is to this. We just broke up x to the 3 plus 64 into x plus 4 times x squared minus 4x plus 16. So first, if I figure out your a cubed and b cubed, from those, figure out a and b. Then with these two pieces, you just follow this to make this. And by the way, this still equals 0. So the first answer should be obvious to you right away. We see that our first answer is going to live in here. And that what value for x makes this 0? The answer is negative 4. Negative 4 is our first solution right there, because that would be based on the 0 factor property. This would be 0, which would gobble up all of this and give us 0. The other two solutions come when this equals 0. And unfortunately, I think we're going to need to use the quadratic formula for this. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, and a equals 1 in this case. So there you go. If that just confused you how I did that, you should look back at part 3 where I explained the quadratic formula. These two negatives become a plus. Negative 4 squared becomes 16. 4 times 16, this is 64 right here, and a minus sign. So let's simplify this a bit. X will equal 4 plus or minus 16 minus 64. Let's see what that is. 16 minus 64 will equal negative 48 all over 2, or 2 times 1. So we're almost there. Let's think. What can go into 48 that I could pull off? And I believe 16 goes into 48. In fact, I think 48 is 16 times 3. And we can take the square root of 16, which is 4. So this simplifies to x equals 4 plus or minus. Oh, also notice we have a negative sign here, so we should take that off. So we're going to get an I. So the square root of 16 becomes 4. So I'm going to write 4i root 3. So the negative sign became an I. 48 became 4 root 3 all over 2. And then we're almost done. Let's simplify it a little bit more. Sorry, I'm kind of going in a circle here. X equals 4 over 2 plus or minus 4 root 3 over 2 with the I on the end. So that means that x is going to equal 2 plus or minus, that cancels, 2 root 3 I, with the I on the outside of the square root. So look at that. We have 2 answers here and 1 answer here. So we have 1 real answer and 2 complex answers. And by the way, notice that we're only, well, I shouldn't spoil this, but we're always going to get an even number of answers here. And notice that the answers are the conjugate of each other. That's kind of cool. Let's do that process one more time. See if you can do this problem on your own before I help you with it. You're going to use this formula up here because it's a minus sign. So m to the 3 minus 27. See if you can get it. All right, I hope you've taken your best shot at it. So see if you can get the answers. We're going to get 3 answers. So let's see. In this case, I have a cubed is m cubed, and b cubed is 27. So that means that a is going to equal m, b will equal 3, because 3 times 3 times 3 is 27. So let's construct it. A minus b is going to be m minus 3. Then I have, it's all positive here, so a squared plus ab. ab in this case would be m times 3, or 3m. Then the formula says I have another plus, and then b squared, well, 3 squared is 9, so there you go. This is equal to 0. Now let's say you're on a test and you can't remember if you did this correctly. Well, if you FOIL this, do m times all of them, negative 3 times all of them, and combine like terms, you should get m to the 3 minus 27. So make sure you check that if you're unsure and you're doing a test. We see that our first answer is going to be m equals 3. And the other 2 answers from this, we're going to have to use the quadratic formula. So I'm going to do it kind of fast because we're running short on time. B squared minus 4ac all over 2a. And I'm just doing quadratic formula on this piece, to be clear. So 9 minus 36. It's negative 27. And that can be broken up. 27 is 9 times 3. So the square root of 9 is 3. So that'll be 3 root 3 over 2 with I on the end. So if you really wanted to, you could plug in this number, including the I, into m right there. And after you do a bunch of like foiling to try to come up with this, when you this number right here should equal positive 27, so that when after you cube it, so that you get 0 in the equation. All right, obviously 3 is an easier answer to see that works. 3 times 3 times 3 is 27, minus 27 is 0. Let's solve this last one really quick. It says solve the following for m. Because m is m squared, m, and then nothing, we can use the quadratic formula on this. Before we do, we subtract h. So here we go. Now we're equal to 0. So now if I do the quadratic formula, I'll get an answer for m. So notice that in this case, here's my a, here's my b, and all of this is the c. Okay, so that's really important. All of that is the c. So let's find out what we can plug in for m to make this entire thing be 0. It would be negative b plus or minus the square root of b squared minus 4 times a times c, which is all of g minus h, divided by 2a. So you can see that the quadratic formula is the same. It's just that instead of numbers here, we now have variables, and sometimes more than one variable representing c. So we're not going to be able to do too much to clean this up, but let's do a little bit. Negative 4 times negative 81 is going to be positive. So this will be d squared plus, and I believe 4 times 81 is 324. Yeah. So 324 times g minus h all over 2 times negative 81, which would be negative 162. So there you go. I'm not really sure how much more you could do to simplify this. You could break it up and put them both over the negative. You could do distributive property here and get 324g minus 324h. I don't really think that simplifies it much, so I think you can probably stop right there. So this would be nice if you had a very complex polynomial with other, I shouldn't say complex, complicated polynomial with different variables becoming your parts. You can actually solve them based on variables. You don't always have to get a number. Whew! So that is quadratics and cubics. Just a quick rundown. Hopefully this was review and it's all coming back to you. If you have any questions, you can leave them in the comments. Please like and subscribe this video if you found it helpful, and I will see you next time for section 1.5. Have a great day. Bye-bye now.